All right, let's dive right into the ultimate quest for 100% reliable AI orchestration. Today, we're unpacking the Agent Command Center, ACC for short. This is essentially the brain managing automated AI tasks. And we're going to look at how its V2 system totally solves a massive vulnerability in modern AI. What actually happens when your connection to the cloud simply fails. We get to look directly at the system's implementation reports to understand exactly how it builds a fail-proof execution engine. I want to kick things off with this number, 27. In software development, building a feature is one thing, right? But proving it actually holds up under pressure is a totally different ballgame. Looking at the reports, it is honestly incredible to see that all 27 out of 27 system tests passed for the new ACC V2 fallback implementation. That establishes immediate, absolute trust. The system doesn't just theoretically survive an outage, we can see it practically passes every single stress test. And you can see that success right here in this test validation block, straight from the CTO's audit report. It really gives off this cinematic, high-tech briefing report vibe. This is a system that is 92% complete overall, but on this specific, absolutely crucial feature of provider resilience, it is operating flawlessly, just completely green across the board. So here's our roadmap for today. We're going to hit point 1, ACC V2 system readiness. Point 2, the multi-provider fallback chain. Point 3, smart cost tiering benefits. Point 4, task bus metadata tracking. And finally, point 5, setting up local Ollama. All right, kicking things off with Section 1, ACC V2 system readiness. Look, anytime you rely on an external AI provider, you introduce risk, right? What happens when your API runs out of credits or your internet just drops? Well, the solution is documented right here in the provider fallback chain implementation report. The architecture is explicitly designed as a local-first monolith. It's built from the ground up to survive outages. So if the internet gets cut, the local queues and memory actually survive. Moving right along to Section 2, the multi-provider fallback chain. Now, this is the exact mechanism the system uses to sever its dependency on any single cloud API. Think of it like a relay race. If the primary runner trips, the baton gets seamlessly passed to the next. Tier 1 is your primary, DeepSeek. It's categorized as low cost. We're talking a fraction of a cent per task. But if DeepSeek's API fails, or say the balance hits 0, ACC logs the error and instantly passes the task to Tier 2, which is Ollama. This is your offline fallback, running locally for absolutely zero cost. If Ollama isn't installed for some reason, it shifts to Tier 3 Claude. That's the premium model for heavy lifting. And if all else fails, it hits Tier 4, the Smart Stub. The execution engine literally never stops moving. Now pay attention to the Smart Stub twist, because it's a real game changer. It is the ultimate safeguard. If every single AI fails, the system doesn't crash, and more importantly, it doesn't hallucinate or pretend to be smart. The Smart Stub honestly flags itself in the system as is real AI result equals false. It provides structured, pattern-based next steps so the workflow can safely park itself or proceed without corrupting your data. It's just a fascinating way to ensure the system maintains absolute truth while staying perfectly reliable. Okay, let's jump right into Section 3, Smart Cost Tiering Benefits. So the fallback chain isn't just about avoiding errors. It's actually a massive strategic financial tool. Notice the dramatic contrast here. On one side, you have pure cloud API dependency, which, let's be honest, is where most people operate. It's completely vulnerable to network outages, and every single query ticks a meter, draining your budget. But on the other side, when the local fallback is active, everything turns bright green. You are suddenly operating at $0. Plus, you get total privacy for sensitive data because the request never even leaves your machine, and you have complete offline capability. The system's zero-cost, free-first operating rules strictly prioritize this local execution whenever possible. Next up, Section 4, Task Bus Metadata Tracking. Because you have 4 different providers potentially running a task, the system obviously needs a really rigorous way to transcribe exactly what happened and who did it. The ACC Task Bus steps in here like a meticulous accountant. Every single time a task finishes, the system stamps it with these exact metadata fields. It records the provider underscore used, like was it Claude or was it Ollama? It logs the cost underscore tier. It permanently stamps is underscore real underscore AI result, so an audit agent can later verify the work. And it tracks the chain attempted, so you can see, if DeepSeek failed and it actually had to route to local. This ensures complete transparency and perfect auditing for every automated decision. And finally, Section 5, setting up local Ollama. All right, it's time to transition from the theory of this system into actual hands-on execution so you can liberate yourself from those API costs. If you want to activate that zero-cost local tier, the instructions are incredibly straightforward. Step 1, you just download the installer directly from Ollama.ai. Step 2, open your terminal and run Ollama serve to start the local server. And step 3, you simply execute Ollama poll Llama 3.1. Doing this basically treats your local machine like its very own secure cloud environment. But the crucial point is really what happens next. The source documents note that the Llama 3.1 model is about 4.7 gigabytes. Once that download finishes, the Agent Command Center auto-detects it instantly. You can see from the status block that there is absolutely no system restart needed. ACC just pings the local health check endpoint, sees their model is available, and immediately incorporates it into the active fallback chain. Literally, your system is instantly upgraded. Which leaves us with this final, kind of provocative question to consider. Is your AI infrastructure truly independent? Seriously, if Anthropic or OpenAI goes offline tomorrow, does your workflow halt entirely? By studying the architecture of ACC v2, we see that true orchestration isn't just about passing prompts to an API. It's about building a multi-layered, highly resilient engine that protects your data, optimizes your costs, and absolutely never stops executing.